Well, grade 12s, what we're going to be doing in this lesson is we're going to continue with trigonometry, an extension from your grade, your grade 11 and 10 days. And we're going to be introducing you to some friends of mine called the compound angle formulas, okay? And a compound angle is really the sum or difference of two angles. And what is quite useful, they give you this on a formula sheet, is that in trigonometry, if you take the sine of A plus B, it's not sine A. If you had to write sine A plus sine B, you would find that that would be incorrect. So it's not that, okay? So it's not that, okay? So the question is, and mathematicians did a bit of research and they'd come up with some amazing formulas, and they discovered that the sine of A plus B is actually, and they give this to you, you don't have to learn it, is the sine of A multiplied by the cos of B, okay, then it's plus the cos of A multiplied by the sine of B there. Okay, so that's what we call a compound angle. There's also one for A minus B. It works like this. This is going to go sine A multiplied by cos B, subtract. We keep the same sign. Cos A sine of B. Okay, and then for your friends, the cos A plus B, there's one, and also for cos A minus B. Now these are the sum and difference of two angles there. Now the cos one, this works pretty interestingly, the cos A plus B, it's cos A cos B, then we sign change, minus sine A sine B. Now this you can go to the formula sheet and get these off, cos A cos B, and that will be plus sine A sine B. So I'm not going to bother too much about the deriving of these formulas, but they're very interesting, and we're going to make use of them a lot. You also get the double angle formulas. The double angle formulas would be where you've got, like, for example, a double angle would be, if you take 40 degrees, it can be written as 2 multiplied by 20. That would be a double angle there, okay? And there's lovely ones for these guys. The sine of 2a is 2 sine A cos A. Can be proved, but we're not going to worry about that now. Okay, sine 2. The cos 2A is a bit of a stranger. This guy, he can be three personalities. He could be cos A squared, cos squared A minus sine squared A. You could have 1 minus 2 sine squared A, or in fact 2 cos squared A minus 1. This is always a problem as to which one to use. And then don't forget your other formulas from earlier years. What is tan A? Well, tan A is sine over cos. And also be very careful when you talk of sine squared A plus cos squared A, you get 1. It could also be cos squared A plus sine squared A is 1. So these are formulas that I'm going to leave up and we're going to use. But and then also don't forget these guys are the negative angles that come up often in compound angles. The sine of negative theta, if you remember, is negative sine. A bit of revision here. Cos of negative theta, you lose the negative. And if you've got the tan of negative theta, then that becomes negative tan theta there. Okay, cool. Okay, so let's apply these things. We obviously, we're going to go through special angles and that. But if we simplify without a calculator, have a look at this. If I said to you, simplify the sine of 70, the cos of 10. Okay, sine of 70 cos 10 minus cos 70 sine 10, and you've got to do that, but you're not allowed to use a calculator, and you had to simplify. Well, none of these are special angles, because with your special angles, if you remember from grade 10 days, you can do that. You could also use a calculator to work them out, like 60, 45, and 30. Those we'll come to. But what do we do here? Well, all I know is that, look, this angle is the same, and this angle is the same, and it seems to me that this is actually the same as if you look at sine A cos B, and that's minus cos A sine B. That is very familiar to me. That is almost a sine A minus B. Let's just go back and check. Okay, sine A minus B. That's a bit untidy. Let's make it nice, look a bit decent there. Okay, so there we go. That looks hot. All right, let's bring it up there. Okay. Okay, have a look at this. The sine of, I'm just going to bring it across so you can see sine of A minus B is sine A cos B minus cos A sine B. Good. Okay, so we've got that there. All right, now, if you think of the A as 70 and the B as 10, in this case, this is going to be, if you look here, that's 70, and that's 10, and that's 70 degrees and 10 degrees. Well, what's nice is this whole mess can be written as sine 70 minus 10. Okay, A minus B. So in other words, that mess that we're dealing with here, so we can say that the sine of 70, the cos of 10, subtract the cos of 70, the sine of 10, is actually very simple. That is actually sine A cos B minus cos A sine B is the sine of 70 minus 10. And guess what? Doing that takes us into special angles, and we've got the sine of 60. And if you remember from the grade 10's lessons, you can always go back and check that if you've got 60 degrees, that was one of those formulas there. Sine is opposite over hypotenuse, which was root 3 over 2. Of course, you can cheat and use your calculator there. It'll give it to you as well. Okay, so that's an important use, different to grade 11, but still using those kind of things. I think we should try another one. What about this one? See if you can do this here. If I said to you cos of 50, now that's not special. Cos of 20, ooh, cos, plus the sine of 50, sine of 20. Well, let's see, is there a formula for cos plus sine? Let's go up and look. Okay, cos plus sine is this one, so it's cos A minus B. So what we can then do is, if we go down again, this is, if that's your A and your B, the A is the same as the B there. The A and B are that A is equal to A, B is equal to B. So you can say this equals cos A minus B, which of course is 50 minus 20. There we go, 50 minus 20, which of course is cos 30 degrees. And if you look at 30 degrees, if we go back to our special angle triangles there, the cos of 30 is root 3. It's adjacent over hypotenuse, which is root 3 over 2. Okay, again, quite nice. It's applications of just something more than, a little bit extended compared to what you did in your grade 11 days. Okay, how about this one? Okay, if we bring in, say, now this one's a very interesting one, because if you've got cos of negative 15, well, that's not special, but we can firstly say, well, the cos of a negative is just the positive, but this is not a special angle. But if we express it as this, we could say that that is actually 45 degrees, which is special, minus that special angle there. 45 minus 30 is 15, and that's a cos A minus B, which, if you think about it, is actually, if you use the formula at the top there, is cos A cos B plus sine A sine B. That's the formula. I've just taken it from the top there. So if we apply that, it's cos 45 cos 30 plus sine 45 sine of 30. Okay, and these are special angles. Remember 45, if you use the cell school method that I taught you in grade 10, it looks like that. You can use a calculator. There's many other ways, but cos is adjacent over hypotenuse, which is the root 2 over 2. Cos of 30, if you remember, was root 3 over 2, same as before. Just double check that. Cos 30 we've got, and then we've got the sine of 45. That's ugly. We've got the sine of 45, which is going to be, let's have a look at, let's just do that, plus the sine of 45, which again, if that's 45 there, it's opposite over hypotenuse, root 2 over 2, and the sine of 30 is a half. If you look at 30 degrees, let's just go up to our triangle. 30 sine is opposite over hypotenuse, which is half. Once again, you can always check those in the calculator. Cos 45, it works for you. And then root 2 times root 3 is going to clearly give me, if you look at this, it's going to give me the root of 6 over 4, and then plus the root of 2 over 4 there. So if you put that all together, it's the root of 6 plus the root of 2. And there we go. Cos plus sine. Okay. Alright, so the answer then is root 6 plus root 2 over 4. Okay, how would we do number D? Well, let's look at this. This is the sine of negative 285. Now be very careful here. With sine negative, the negative comes out. Okay, now this is going to be, if you remember from grade 11 days, it's bigger than 270, which is there, but less than 360, so it's in there. So it's going to be, remember the rule was 360 minus something, which of course is 75. 360 minus 75 is going to give you your 285 there. Then in this quadrant, sign is negative, so it reduces to negative sign 75. If you go back to your grade 11 notes at school, you'll be able to do that, or just pick up on our notes there, or our lessons. Go back to our lessons and in grade 11, and you can get that. Okay, now sine 75, okay, again can be written as 45 as a compound angle, 45 plus 30. And then if we apply the little rules, that's sine A plus B, which would then be sine A cos B plus cos A sine of B there. Okay, and then if we simply work out the special angles, root 2 over 2 for sine, cos of 30 root 3 over 2, cos of 45 root 2 over 2, and sine of 30 is a half. And if we look at that again, it's quite interesting. It actually comes to root 6 over 4. Interesting, almost not all the problems will work out exactly the same, but this is interesting. That actually worked out very nicely. It's almost like the other, but I wonder why it did. If you look, why did these come, cos 15 and sine 75? Why was cos 15 the same answer as sine 75? Well, if you think about that, if you remember, just to revise this from earlier years, remember 15 is 90 minus 75, and then from the co-rules that comes to sine 75. So that's why I deliberately put that one in there, because you can see that they're exactly the same, and you need this later on as we go through the lesson. So remember, cos of 90 minus is sine.